Potassium dichromate is prepared from chromate ore. The ore is concentrated by gravity separation. It is then mixed with excess sodium carbonate and lime and roasted in a reverberatory furnace. The roasted mass is treated with water to separate soluble sodium chromate from insoluble iron oxide. The yellow solution of sodium chromate is treated with concentrated sulfuric acid, which converts sodium chromate into sodium dichromate. The above solution is concentrated to remove less soluble sodium sulfate. The resulting solution is filtered and further concentrated. It is cooled to get the crystals of sodium Na2SO4 to H2O. The sodium sulfate, the saturated solution of sodium dichromate is mixed in water, is mixed with KCl and then concentrated to get crystals of sodium chloride. It is filtered with hot and the filter is cooled to obtain K2Cr2O7 crystals. Potassium dichromate is an orange-red crystalline solid which melts at 671 Kelvin, and it is moderately soluble in cold water but very much soluble in hot water. On heating, it decomposes and forms Cr2O3 and molecular oxygen. As it emits toxic chromium fumes upon heating, it is mainly replaced by sodium dichromate. Both chromate and dichromate are oxo ions of chromium, and they are moderately strong oxidizing agents. In these ions, chromium is in +6 oxidation state. In an aqueous solution, chromate and dichromate ions are interconvertible, and in alkali solution, chromate ion is predominant, whereas dichromate ion becomes predominant in acidic solutions. Structures of these ions are shown. Potassium dichromate is a powerful oxidizing agent in acidic medium. It is oxidizing agent in the presence of H plus ion. You can note the change in the oxidation stage of chromium from C6 plus to Cr3 plus. Its oxidation action is shown below. The oxidation nature of potassium dichromate ion is illustrated. It oxidizes ferrous salts to ferric salts, and iodide ions to iodine ions, sulfide to sulfur, and sulfur dioxide to sulfate ion, stannous salt to stannic salt. It oxidizes alcohols to acids. When potassium dichromate is heated with any chloride salt in the presence of concentrated sulfuric acid, orange vapors of chromyl chloride is evolved. In this reaction is used to confirm the presence of chloride ion in inorganic qualitative analysis. The chromyl chloride vapors are dissolved in sodium hydroxide solution and then acidified with acetic acid and treated with lead acetate. A yellow precipitate of lead chromate is obtained. Some important uses of potassium dichromate are: it is used as a strong oxidizing agent, it is used in dyeing and printing, it is used in leather tanneries for chrome tanning, it is used in quantitative analysis for the estimation of ion compounds and iodides. Potassium permanganate is prepared from pyrolusite MnO2 ore. The preparation involves the following steps: conversion of MnO2 to potassium manganate. Powdered ore is fused with KOH in the presence of air or oxidizing agents like KNO3 or KClO3. A green colored potassium manganate is formed. MnO2 plus KOH plus O2 gives K2MnO4 plus 2H2O, potassium manganate. Oxidation of potassium manganate to potassium permanganate. Potassium manganate thus obtained can be oxidized in two ways, either by chemical oxidation or electrolytic oxidation. In this method, potassium manganate is treated with ozone O3 to chlorine to get potassium permanganate. KMnO4 plus O3 plus H2O gives KMnO4 plus OH minus plus O2, MnO4 plus Cl2 plus MnO4 plus Cl. In this method, aqueous solution of potassium manganate is electrolyzed in the presence of little alkali. K2MnO4 plus 2K plus MnO4 plus H2 gives residual H plus OH. Manganate ions are converted into permanganate ions at anode. MnO4 plus MnO4 minus plus 2E minus H2 is liberated at the cathode. The purple colored solution is concentrated by evaporation and forms crystals of potassium permanganate on cooling. Potassium permanganate exists in the form of dark purple crystals which melts at 513 Kelvin. It is sparingly soluble in cold water but fairly soluble in hot water. When heated, potassium permanganate decomposes to form potassium manganate and potassium manganese dioxide. On action of untreated with concentrated sulfuric acid, it decomposes to form manganese septoxide, which subsequently decomposes explosively. But with concentrated hot sulfuric acid, potassium permanganate gives MnSO4. KMnO4 plus H2SO4 gives MnSO4 plus K2SO4 plus H2O plus O2. Potassium permanganate is a strong oxidizing agent. Its oxidizing action differs in different reaction medium. It oxidizes H2S to sulfur. It oxidizes thiosulfate into sulfate. In the presence of alkali metal hydroxides, the permanganate ion is converted into manganate. This manganate is further reduced by MnO2 by reducing agents. So, cold dilute alkaline KMnO4 is known as Bayer's reagent. It is used to oxidize alkanes to diols into diols. For example, ethylene can be converted into ethylene glycol, and this reaction is used as a test for unsaturation. In the presence of dilute sulfuric acid, potassium permanganate acts as a very strong oxidizing agent. Permanganate ion is converted into Mn2 plus ion. MnO4 minus plus H2 8H plus 5E gives Mn2 plus 4H2O. The oxidizing nature of potassium permanganate in acidic medium is illustrated as ferrous to ferric salts, iodine to iodides, iodide to iodine salts, oxalic acid to CO2, sulfur ion to sulfur, nitrites to nitrates, alcohols to aldehydes, and sulfide to sulfate. Potassium permanganate is a strong oxidizing agent. It is used for the treatment of various skin infections and fungal infections of the foot. It is used in water treatment industries to remove iron and hydrogen sulfide from well water. It is used as Bayer's reagent for detecting unsaturation in an organic compound. It is used in quantitative analysis for the estimation of ferrous salts, oxalates, hydrogen peroxide, and iodides. HCl cannot be used for making the medium acidic since it reacts with KMnO4. HNO3 also cannot be used since it is a good oxidizing agent and reacts with reducing agents in the reaction. H2SO4 is found to be more suitable since it does not react with potassium permanganate.